Assalamualaikum and hi everyone. Welcome back to LU6 Molecules and Molecular Structure. For today's lecture, we're gonna learn more about 6.4 molecular shape. By the end of this lecture, you should be able to differentiate the shape of ionic compounds with covalent compounds, identify shape of covalent compounds, explain the effect of lone pair and electronegativity on the shape of covalent compounds, predict the shape of covalent compounds, and lastly, explain bonding theory. Covalent bonds are highly directional. It prefers specific orientation in space relative to one another. As a result, molecules with more than two atoms which are bonded having a very definite shape. Some of the molecules have different arrangement of electron pairs around central atom. So how does we determine the shape of a molecules? The shape of molecules can be predicted by the valence shell electron pair repulsion or VSEPR theory. VSEPR theory is used to predict a molecular shape of a molecule. Please take note that for VSEPR theory, we will focus on the central atoms of the molecule. Some rules need to be followed to predict the shape of a molecule. The electron pairs around the central atom repel each other. The electron pairs here mean that it's either a lone pair or a bond pair. A lone pair can exert a greater repelling effect than a bonding pair. The order of repulsion between electron pairs is the repulsion between a lone pair against another lone pair is stronger than the repulsion between lone pair against a bond pair. And the weakest repulsion is between a bond pair against another bond pair. For molecules and ions that do not contain lone pairs of electrons, the shape of the molecule or ion is the same as the geometry of electron pairs. There are 5 basic geometry of electron pairs. Please remember that electron pairs here mean that it either contain a bonding pair or a lone pair, or both of them. When the total number of electron pairs is equal to 2, the geometrical arrangement of electron pairs or the geometrical shape is linear. When it has 3 electron pairs, the geometrical shape is trigonal planar. When the number of electron pairs is 4, the shape is tetrahedral. When the number of electron pairs is 5, it will have a geometrical shape of trigonal bipyramidal. And lastly, when the number of electron pairs is equal to 6, the geometrical shape is equal to octahedral. These are some of the examples for the shape of a common molecule. So for the first example, which we have a BCl3 or boron chloride. So how does we determine the shape for boron chloride? So to determine the shape for boron chloride or BCl3, first thing you need to do is you need to draw the Lewis structure for BCl3 first. And please make sure that when you draw a Lewis structure for a molecule, you need to draw the best Lewis structure for the molecule. After you have drawn the Lewis structure for the molecule, you need to determine the number of electron pair exists in the molecule. And remember that electron pairs mean that it either contain a lone pair or a bonding pair. So for BCl3, as you can see here, it has 3 bonding pair, 1, 2, 3. And based from the rules on how to predict a molecular shape by using VSEPR theory, when a molecule or ion does not contain any lone pair, it can follow the basic shape of the molecular geometry. So this BCl3 only have three bonding pair and zero lone pair. So that means that it only has the shape of the basic molecular geometry. So based from the five basic molecular geometry, when it has three bonding pair, it will have the shape of a trigonal planar. When you have determined the shape for the Lewis structure of BCl3, you need to draw the Lewis structure for BCl3 according to the shape. So right now, the shape for BCl3 is trigonal planar. So then you need to draw the Lewis structure according to trigonal planar. So as you can see, to draw the shape, to draw the Lewis structure based on trigonal planar, the central atom, of course, must need to be the center, and the side atom will be spread in the shape of a triangular. As you can see here, between all of these side atom, when you connected the side atom, you will have a triangular shape. So that's why the name of the shape is trigonal planar. Next, you have methane CH4. So first thing first, when you need to determine the shape of a molecule, you need to draw the Lewis structure for CH4. If you doesn't know the shape first, you can draw the Lewis structure by a very simple Lewis structure. So the very simple Lewis structure for CH4, you can just draw it from the basic. You can just draw a simple Lewis structure first without without the shape. When you have drawn the best Lewis structure for CH4, next thing you need to do is you need to determine the total number of electron pairs. So right now, the carbon atom doesn't have any lone pairs. It only has 4 bonding pairs, 1, 2, 3, 4. So based from the basic geometry, when you have 4 bonding pairs, the shape is gonna be tetrahedral. Next, when you have determined the shape of the molecule, you need to draw the Lewis structure based from the shape of molecule. To draw the shape of tetrahedral, this is the way on how you draw the Lewis structure of a tetrahedral. For PCl5, next example, PCl5. So first thing first, you need to draw the Lewis structure. So if you don't know the Lewis structure, or you don't know the best Lewis structure for PCl5, you need to do the formal charge. After you have determined the best Lewis structure for the PCl5, next thing you need to do is you just draw the Lewis structure, not according to shape if you don't know the shape first. So just draw it very simple, and then next, when you have drawn the Lewis structure, you need to determine the total number of electron pair exists. So right now the phosphorus doesn't have any lone pair, but it has 5 bonding pair. And based from the basic molecular geometry, when the molecule has 5 number of electron pairs, it will have the shape of trigonal bipyramidal. So after you have determined the shape for the molecule, you need to draw the Lewis structure based on the shape. So on this is the Lewis structure of PCl5 following the shape. So this is the shape for trigonal bipyramidal. So as you can see here, when you connect all the side atom, so you will have a triangular or trigonal, and then when you connect it to the up side atom, you can have a pyramidal. And of course, when you do the same at the bottom side atom, you will also have a pyramidal. And the same thing goes for the sulfur fluoride SF6. So first thing first you need to do is of course to draw the Lewis structure. So if you don't know the shape of the molecules first, you can just draw the shape of the molecule by the basic Lewis structure, you can just put the side atom at any places first, and then when you already drawn the best Lewis structure, you need to determine the number of electron pairs. When you have determined the number of electron pairs, so you can just refer to the basic geometry molecule shape. So for SF6, it will have 6 bonding pair. So based on the basic geometrical shape, when you have 6 electron pairs, the shape is gonna be octahedral. So for each of the Lewis structure, when you draw it according to the shape, there will be a bond angle between all of these side atoms. So the bond angle for each of the shape is also stated below. So for trigonal planar, you will have a 120 degrees angle between the side atom. So between the first Cl and the second Cl, it will have a 120 degree. And the same with the bottom angle, it will also have 120 degrees. So this is what you call as the bond angle. And for tetrahedral, you will have a 109.5 angle between the side atom, 109.5. And for the trigonal bipyramidal, you will have two bond angle. The first one is 90 degree. The 90 degree come from the bottom side atom and the planar side atom. So this is 90 degree. And the second one is 120 degree. So the 120 degree come from the angle between the planar side atom. So this is 120. So you have learned the 5 basic geometry of a molecule based from their total number of electrons. And from the previous example, all of the molecules only contain a bonding pair for their electron pairs. So what if there is a lone pair exists in the electron pairs? So what are the effects of lone pair electron on the shape of molecules? For molecules and ions that contain lone pair of electrons, the shape of the molecule or ions is different from the geometry of electron pairs. These shapes are called molecular shapes and refer to the position of the atoms around the center atom. Example 1. Molecules with 4 electron pairs. Based from the 5 basic geometry, you know that when the molecules contain 4 electron pairs, it will have the shape of a tetrahedral. But when the electron pairs also contain a lone pair, there are 3 molecular shapes corresponding to 4 electron pairs that are arranged in tetrahedral orientation. So for the first molecular shape is, for example, methane CH4. For the first molecular shape, it only contains 4 bonding pairs and 0 lone pairs. So following the basic geometry, it will have a total electron pairs equal to 4, so the shape is still tetrahedral. Next, when you have example ammonia NH3, the lone pair for ammonia is equal to 1. Ammonia will have 1 lone pair and 3 bonding pairs. 1, 2, 3. So the total number of electron pairs is equal to 3 bonding pair plus 1 lone pair. So it will have a total number of 4 electron pair for ammonia. According to the basic geometry, When you have four total number of electron pair, it's supposed to have the shape of tetrahedral. But with these cases of having a lone pair, the shape of the molecular shape will be different from tetrahedral. It will have a shape of pyramidal when you have one lone pair. Next, when you have water, H2O, so the number of pairs exist in H2O is two bonding pair, 1 and 2. So two bonding pair for water and two lone pair for water. So two lone pair. So the total number of electron pair for H2O is 4 electron pairs. So according to the basic geometry, it's supposed to have the shape of tetrahedral, but since water have two lone pair, it will have the shape of a V shape or band. Example 2. Molecules with 5 electron pairs. If the central atom is surrounded by 5 electron pairs, the lone pairs of electron will always occupy the space in the triangular plane, which is the equatorial position. So based from the 5 basic geometry, when you have 5 electron pairs, it's supposed to have the shape of trigonal bipyramidal. So you have the central atom, the trigonal plane, and the vertical plane. So this is an example of a trigonal bipyramidal. So you have 5 side atoms. So the vertical side atom and the horizontal side atom. So what does this statement mean is that when you have a lone pair, the lone pair will always occupy the horizontal plane first rather than the vertical plane. So when you have one lone pair, so it will occupy the triangular plane, which is the horizontal plane. And when you have London pairs, it will have the shape of a seesaw shape. When you have two lone pairs and three bonding pairs, so 1, 2, 3 bonding pairs, and two lone pairs, it will have the shape of a T shape. Example 3. Molecules with 6 electron pairs. If a molecule has 6 electron pairs, the lone pair will always occupy the axial position. So different from the molecules with 5 electron pairs. So when the molecule with 5 electron pairs, the lone pair will always choose the equatorial plane first. But for the molecules with 6 electron pairs, the molecules will always occupy the axial plane or the vertical plane that you draw. As an example, for xenon tetrafluoride will have two lone pair. So the lone pair will both occupy the vertical plane and the shape will be the square planar. These are some of the notes that may help you on how to differentiate molecular shape and the geometry of electron pairs. You have learned the 5 basic geometry of electron pairs before. So for the first geometry, which is linear, linear have 2 electron pairs. So for the molecular shape will depend on what is the type of pairs exist in the molecule. So for the first cases, which is when the linear have two bonding pairs, the molecular shape will be the same as the geometry, which is a linear. Next, for trigonal planar, which consists of 3 electron pairs, for the first cases, when the molecule consists of 3 bonding pairs, the molecular shape will still be the same as the geometry, which is trigonal planar. The next cases, when the electron pairs consist of one lone pair and two bonding pair, the molecular shape will be different from the geometry. You will get the molecular shape of a band shape or V shape. Next, when the number of electron pairs is equal to 4, you will get the geometry of the electron pairs is equal to tetrahedral. For the molecular shape of tetrahedral, if all the electron pairs consist of bonding pairs, 4 bonding pairs, you will have the molecular shape the same as the geometry, which is also a tetrahedral. The second cases, which is if the electron pairs consist of 3 bonding pairs and 1 electron pairs, the molecular shape will be a trigonal pyramidal. And lastly, if the electron pair consists of 2 lone pair and 2 bonding pair, the molecular shape for the molecule will be a band or a V shape. For trigonal bipyramidal, which consists of 5 electron pair, for the first cases, where the electron pair consists of 5 bonding pair, the molecular shape will still be the same as the geometry, which is also a trigonal bipyramidal. The next cases, when the electron pair consists of 4 bonding pair and 1 electron pair, the molecular shape will be a seesaw. Please remember that for the molecule that consists of 5 electron pair, the lone pair will always occupy the horizontal plane or the equatorial plane. So for the trigonal bipyramidal, the lone pair will always occupy the equatorial plane. So this is the lone pair for the second cases. So when you rotate this shape 90 degrees to the left, you will get the shape of a seesaw. For the next cases, when the electron pair consists of 3 bonding pairs and 2 lone pairs, the molecular shape will be a T shape. And please remember that for the molecule which contain 5 electron pair, the lone pair will always occupy the equatorial plane. So the second lone pair, for example, will occupy these places. So when you rotate this trigonal bipyramidal at different angle, you will get the T shape. And lastly, when the electron pair consists of 2 bonding pair and 3 lone pair, the molecular shape will be a linear. And of course, the last lone pair will also occupy all of the equatorial plane or the horizontal plane. Okay, so this is your third lone pair. So as you can see here, you will get a linear molecular shape. So this is the linear molecular shape. And the last geometry of electron pairs is octahedral, where the electron pairs is equal to 6. So for the first cases, for the molecular shape, when the electron pair consists of 6 bonding pair, the molecular shape will still be the same as the geometry, which is also an octahedral. The second cases, if the electron pair consists of 5 bonding pair and 1 lone pair, the molecular shape will be a square pyramidal. Please remember that for a molecule that consists of 6 electron pair, the lone pair will always occupy the vertical plane or the axis plane. So for example, the first lone pair you will get here. So as you can see, you will get a square pyramidal. If you connect all of the side atom, you will get a square pyramidal. Next, if the electron pair consists of 6 4 bonding pair and 2 lone pair. The total number of electron pair is also 6. And please remember that for a molecule that consists of 6 electron pair, the lone pair will always occupy the axis, the vertical axis. So the second lone pair will be here. And as you can see here, the molecular shape will become a square planar. So the planar, this is a square and it's a plane. So it's a square planar. Exercise 1. According to VSEPR theory, draw the molecular shape of water H2O. So to determine the molecular shape of water, you need to draw the Lewis structure of water first. So how we need to draw the Lewis structure. So based from the previous lesson, to draw the Lewis structure of water, the best Lewis structure of water, you need to list out all of the atoms inside the molecule, which is O and H. And then you need to find out the total of valence electron. So for oxygen, the valence electron is 6, and for hydrogen, the valence electron is 1. But times by 2 since the hydrogen atom has 2, so the total number of valence electron will be equal to 8. Next, you need to determine between the O and H which one will be the central atom. For water, O will become the central atom. This is because hydrogen is not possible to become a central atom because a central atom need to form more than one bond with the side atom, and hydrogen can only have a duplet configuration. After you have determined the central atom, you need to draw the side atom, and you need to spend all of the total electron. So the oxygen will form a bond with hydrogen. So one bond is equal to 2 electrons. So that means we have spent a total of 4 electrons already. So the left will equal to 4. So since the hydrogen have already achieved stability, which is a duplet configuration, so the left electron will be put at the central atom as a lone pair. So you can put 4 electron at the oxygen as a lone pair. Next, you can find the formal charge of the Lewis structure to determine whether it is the best Lewis structure for water. But this is the best Lewis structure for water already because oxygen cannot form a double bond with H, since hydrogen can only achieve a duplet configuration. So if it forms a double bond with H, it will have 4 electrons, which is not possible. Next, after you have drawn the Lewis structure, next thing you need to do is to find the number of electron pair. So for water, as you can see, there is 2 bonding pair and 2 electron pair. So 2 lone pair plus 2 bonding pair, water will have a total number of 4 electron pair. And the basic geometry for a 4 electron pair is equal to tetrahedral. But please take note that for water, it has 2 lone pair. So the molecular shape will be different. And based from the previous slide, you know that when a tetrahedral consists of 2 lone pair, its shape will become a V shape. So the next thing you need to do is you need to draw the Lewis structure based on the shape. So the V shape, and please make sure that the bond angle is correct. And you can put the lone pair at the top of the oxygen. So this is the molecular shape of water. You have learned about the bond angle for each of the molecular shape. So what is the effect of electronegativity on the bond angle for each of the shape? So for example, you have H2O and H2S. So as you can see here, both of these molecules have the same shape, which is V shape. So what differ for each of these molecules is the bond angle. Oxygen is more electronegative than sulfur. According to the predictable trend, oxygen and sulfur are in the same group. So going down the group, the electronegativity will decrease because sulfur located at the bottom of oxygen. The bond pair of electrons in OH bond are drawn closer to oxygen atom in H2O. As a result, the repulsion between the bonding pair is increased, thus the bond angle in H2O is greater. So for H2O, the bond between O and H, for the bonding pair, the electron will be attracted toward oxygen rather than the hydrogen. This is because oxygen is more electronegative than hydrogen. So this is the example. So you have this bonding, the electron cloud. So when both of these electron cloud from the blue electron cloud and the red electron cloud are collided at the center at the oxygen, so it will push the bonding pair further from each other. So that's why the bond angle is high rather than the sulfur and hydrogen. So even though the electron cloud also favored toward the sulfur because sulfur is more electronegative than hydrogen, but the difference between the H2S and H2O is oxygen is more electronegative than sulfur, so that's why the repulsion between the SH bond is lower than the repulsion between OH bond. Another example on the effect of electronegativity on the bond angle is NH3 and NF3. So both of these molecules has the same shape, which is trigonal pyramidal, but F is more electronegative than H atom. The bonding pair in NF is closer to the F atom and further from the central atom, which is N. Thus, the repulsion between the bonding pair in the NF3 molecule is less than that in NH3 molecule. So as you can see, in between the bond of F and N, the electron will favor the F rather than N because F is more electronegative. So this is all the electron cloud between the bond of N and F. So as you can see at the central atom, there is not much of the electron gathered. So when there is not much electron gathered here, the bond angle will be lower because the force of repulsion is less. But for N and H, the electron cloud will be favored toward the nitrogen because nitrogen is more electronegative. So this is the electron cloud for the NH bond. So as you can see, most of the electron cloud are located at the end. So that will result in the more repulsion between the bonding pair. So that's why the bond angle for NH is larger than NF3. And that's it for today's lecture. So I hope that you will always remember about the basic geometry shape and also the molecular shape. And please don't forget about the bond angle for each of the molecular shape. So that's it for today's lecture. I hope that you have fun and see you again on the next lecture, which is also a 6.4 molecular shapes. Thank you and have a good day.